All right. So same situation as before. Strings of lengths 10, symbols A, B, C, D. We're going to compute the cardinality of A1 union A2. Remember what this is saying was, this is saying how many strings of length 10, where the symbols come from A, B, C, D, have 3 C's and 2 D's, or 2 D's and 5 A's. Okay. All right, so strings with 3 C's and 2 D's. First, let's look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, length 10, right? So we got 10 positions total. 10 positions. We've got 3 C's and 2 D's. Okay, so we got 10 positions. We choose 3 of them to be C's. All right, so cardinality of A1. We have 10 positions, choose 3 to be C's. C, C, C. Okay. So we've got 10, choose 3. Now, once we've chosen those 3 positions, now we choose 2 to be D's. Let's say D and D. Okay, so once we chose 3 of those positions to be C's, then we had 1, 2, 3, 4, 5, 6, 7. So 7 positions, choose 2 of them to be D's. And then what's left over, then we have 2 choices for each of the remaining. So we got 2 choices, 2 choices, 2 choices, 2 choices, 2 choices. So 1, 2, 3, 4, 5 times 2 to the 5th. Okay, so again, 10 positions here. Positions. Okay, so we got 2 D's. Let's say D and D, we chose those. Okay, so the cardinality of A2. 10 positions, choose 2 of them to be D's. D's. All right, I should have done that right there, right? This was computing C's, this was computing D's, and this is A or B. Let's say A's or B's. A's or B's. A's or B's. Okay, so we got those. Now there's 8 positions left over. We're going to choose 5 of them to be A's. This is my A's. So we've got 1, 2, 3, 4, 5, something like that. Now we've got 2 choices left over. So we got 2 choices, 2 choices, 2 choices. So 2 cubed times 2 cubed. Okay, all right, let's see. Okay, so now we got to get, now we want to find the cardinality of A1 union A2. So we got cardinality of A1 plus cardinality of A2 minus cardinality of A1 intersect A2. Now think of this last one, right? This is the number of strings of length 10 that have 3 C's and 2 D's and 2 D's and 5 A's. Now, is there anything in there? Is there any strings that have 3 C's, 2 D's, and 5 A's? Sure. Right? There's going to be some strings of length 10 from symbols A, B, C, D that have 3 C's, 2 D's, and 5 A's. So this would not be 0. So there is something there. There is something that we're overcounting when we count just these and add that to just these. There's something in the intersection, right? There's something that's counted twice when you count this and you count that. Okay, that's why we got to subtract it off. Okay, all right, so this, like we found there, was 10 choose 3, 7 choose 2, times 2 to the 5th, plus, let's see, A2, we found 10 choose 2, 8 choose 5, 2 cubed, and now we got to subtract, figure out what we're going to subtract off. Okay, so A1 intersect A2. So be strings with 3 C's, and 2 D's, and 2 D's and 5 A's. Okay, we could say and 2 D's, but there's no point, right? Because we've already said it here. So that's a little redundant. 5 A's. Okay. Yes, I do. I just realized that I should say exactly, right? I should say exactly. So in all of these that I'm doing here, I meant exactly 3 C's, exactly 2 D's. So A1 was exactly 3 C's and exactly 2 D's, and A2 was exactly 2 D's and exactly 5 A's. Okay, so we'll say exactly. Right. So that won't be any ambiguity there. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positions, 3 C's. So you have 10 choose 3 for the C's. Let's see, 1, 2, 3. Say those went there. Right, then we have 7 positions. And 2 for the D's, so this will be the C's, this is the D's. Okay, there, and there. And now 5 A's. 5 A's. Let's see, you've got 1, 2, 3, 4, 5. You have 5, choose 5. Okay, and so then we see that here we have 10 choose 3, 7 choose 2, 5 choose 5. Okay, so what you may notice, remember that 5 choose 5 is 1. So we really don't have to have that on the end. We can write that, 5 choose 5 is perfectly fine. You could just eliminate it because it's just a 1, all right? So what is this saying now? Is this saying that there's only one place that this is exactly how it looks? We only have the 5 A's and this position? That's not what it's saying. Okay, it's not saying that the 5 A's are always going to go in the first position and the last 4 positions. That's not what that's saying. That's basically what that's saying is once we choose the 3 places for the C's, and then we choose the 2 places for the D's, then there's only one way to put in the 5 remaining A's. Okay, it's not saying that the 5 remaining A's will always look like this. They'll be all over the place. Another situation, let's see, 3, 4, 5, 6, 7, 8, 9, 10. Let's see, this is 3 C's. Let's do C, 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 2 D's, there, and there. Now there's only 5 remaining positions. I guess this isn't a good one. Let's put the C right there. Okay. All right. Now there's only so what this is saying, why this 5 choose 5 here at the end? What that's counting Once you choose the three positions out of 10 for the C's, and then 2 positions out of the remaining 7 positions for the D's, that there's only one way to go about choosing the 5 remaining A's. So that's why it's 5 choose 5 is 1 there. Many possible ways that these A's might end up when we count A1 intersect A2. But once these are chosen, once those are chosen, there's only one possible choice at the end, right? Once you choose those, there's only one choice. Which all the remaining positions have to be A's. That's just saying, once you choose those, there's only one choice. But that's once you choose those. Once you choose those, then all that remains is one choice.